PCB Way, prototype the easy way. When you shop with these guys, you can get PCBs, 10 pieces for $5. You also get fast turnaround times. You get CNC machining, 3D printing, sheet metal fab, injection molding. I myself love the 3D printing service. You upload your CAD file, choose your materials, and in 2 to 3 business days, your part is on its way. Thank you, PCB Way, for sponsoring this video. Alright guys, so welcome back to my temporary bat cage here, bat cave. So I've got this 5-pole rotor. I needed to reprint these caps here for the bearings that are in here. So I have a bearing in here, 2 bearings in there, and a bearing down here. And of course this is a maglev, so it just floats. I had to reprint these because the white ones that I had on there were way too loose. I don't know what I was doing with those on there. And I'm going to run it because these are disc magnets in here. There's 5 of them, and the poles are on the top and the bottom of it. And so yeah, let me I'm gonna run it off of these guys here, which are bifilar pancake type coils. I call them decoils, and they get really good output, which goes into this bridge rectifier, which is really cool. So let me get it set up and I'll bring you guys back. Alright, so I'm printing out some stands for this. I could just move this up and down, but I like it when it's a little bit higher. So I've got one underneath there. I'm printing out the second one from underneath there. So I've got this guy. Both of these coils are attached to the dual JL94 circuit right there. And then this guy also has one coming out here to the bridge rectifier, coming to the meter. So I'm waiting. I could turn it on now and we can see what it's like. I got something going on. Oh, I see what's going on. Okay. This guy got disconnected. Alright. Yeah, we got 152 volts coming off of that bridge rectifier. That's pretty cool. That's a lot. That's a lot more than what I suspected, and it's about a good 1 centimeter away from the coil. Once I lift it up there, it'll probably be even more. But yeah, 152 coming off the bridge. Let me shut this guy down. Alright, I'm going to go back and get I have to go watch the printer, because when I have a full roll on the A1, sometimes it gets tangled. I have to print out a detangler system for it. Sorry about that. I'm still getting used to this new camera. Finally got a regular name brand camera. Stop messing around. I have to figure out the audio stuff though. But I hit the wrong button anyway. I'm almost done printing out the other side of this guy. That's really close, but this is the one that was putting out all the power on the bridge rectifier. I had some clown in the comments tell me, oh, you can't do it with 5. You could do it with as few or as many as you want. Well, actually, no. To a certain point, like if I tried to do 10 on here, they'd be too close together. Now, granted, 5 is kind of weird because you have 2 magnets that are the same pole next to each other, because you got north, south, north, south, north, north, south. So Yeah, it's better with 6, but it'll definitely work with 5. But let me go back and see if my printing is done. Oh, I was telling you that when I'm printing with a new roll, thank God for the detection system on the A1, because when it gets tangled, it stops it and doesn't tear anything up. You just untangle it and hit resume. But it's because of where the spool is. And so I downloaded a new setup that I can print, and it's supposed to help not tangle. I don't know, something like that. Anyway, stay tuned. All right, so let's see what we got here. Oh, shit. Dang nabbit. That's what I get for being stupid. Okay. There we go. All right, let's see. Let me turn those lights away because they're too bright. There we go. And let me turn this one on. There we go. All right, let's see what we got here. Yeah, 149, 148 volts coming off that bridge rectifier. And those are not big magnets, but those are really good coils. Here, let me put this guy down like that. Yeah, so I got 12 volts coming in. Let me turn it down a little bit. 10 volts coming in. 10 volts coming in. And out of the bridge rectifier, I got 142 volts. Probably not a lot of amps. I could put this on amps. And it's supposed to be able to tell me. So, milliamps. I guess that's 140. I know that's not how you're supposed to measure amps, but yeah, that didn't come out too bad. I had to print, let me turn it off. I had to print, and it's spinning in all 6 bearings. It's spinning on the shaft, it's spinning up in the 2 bearings there. I don't know if the camera is still recording or not, because the screen went blank. Oh, there we go. Yeah, I guess the screen just turns off sometimes. I don't know. I got to figure this puppy out. But yeah, that's not a bad rotor. I had to print a couple of spacers to hold the bearings in. Oops. Got to be careful because it is a maglev. Anyway, I want to do something else with this. So let me bring you guys back a little bit later. Ciao. All right. So here's my VCR bearing with my 1-inch cube magnets in there. Let me fire this puppy up. Yeah, 142 out, 11 in. That's a beast right there. And the VCR bearing really makes it good. So I've got it running off of one side of the JL94 circuit. You can see only one of the lights are lit up. This other side's going into the bridge rectifier there. Oops. Come on, man. Focus, you. There it goes. Going into the bridge rectifier. That is a nice and smooth bearing. Wow. Could watch that all day. See what else? It's still putting out the same amount. 138 volts coming out. 10 going in, or 11 going in. Let's turn it up. There's 14. Yeah, now it's starting to raise up here too. 151. That's a little too dangerous for me. Let me turn it back down. Put it on like 8, 9 volts. I love that VCR bearing stand. I wanted to try to take the current rotor off of it and put it on this guy here, but I'm gonna have to make a new one because that was a press fit on there. Oh well, I'll see what I can do. Stay tuned. You know what I just realized with this rotor? This rotor's not set up to work this way because the poles are on either side here, but it still ran really well. I just realized that. This is actually set up to run like this. That's kind of weird. I guess it really doesn't make any difference though. Even though the poles are this way, they're still opposite. That's still a north, that's still a south. And it's still getting its power from the coil regardless. But it ran really good that way, which makes me think about setting up some other ones like that. What do you guys think? Anyway, stay tuned. Alright, so I got the big beefy rotor, and I'm going to run it, instead of running with the coils on the side, I'm going to run them on the bottom. And it works great that way. Got 152 coming off of that bridge rectifier. That is one monster coil, and of course it's maglev. I don't want to press too far down, but it is floating on the what you call it down there. Let me bring you guys down like that. Oh yeah, he's flying. 12 volts in, 139 out, 140 out. And it's running completely the opposite way where I would think it should run, with the coils on the side because the super poles are facing out, but I guess it doesn't make any difference. Let me turn that down, turn it off. That is a nice rotor. It is a beast. Alright guys, thanks for watching. I'm trying to get stuff happening here in this little miniature bat cave of mine. But, what are you gonna do, right?